Good morning, viewers. Today, I want to speak on questions from a test paper of CBSE 10th class mathematics of last year. In the earlier class, I have solved up to the 20th question of S3 test paper of last year. Today, I start from the 21st question of code S3 of the year 2025 of CBSE Mathematics Standard subject. In my lesson part 3, I have solved up to the 20th question. Now, this lesson can be called part 4, and we'll start with 21st question. Huh. The perimeter, the perimeter of a sector of a circle of radius 15 centimeters is 80 centimeters. Find the area of the sector. So it is question 21, part A. The perimeter of a sector of a circle of radius 15 centimeters is 80 centimeters. Find the area of the sector. So perimeter radius is 15 centimeters. Let us call it r, small r. And perimeter, what is perimeter of a circle? For example, this shape, the shaded region shape is in the form of a sector. Okay, here radius is given to be 15 centimeters. And if the sector angle is theta, then radius is 15 centimeters. So if the curved arc length of the sector is smaller, then radius is r, therefore perimeter becomes r plus small l. Okay, therefore, and small l is r into theta. If sector angle is theta, small l is the length of the arc is r into theta. So r is 15 centimeters here, so it is 15 into theta. So perimeter becomes r plus r theta. So it is 2r plus r theta, that is r into 2 plus theta, is given to be 80 centimeters. R is 15. So 15 into 2 plus theta is 80. From that we can solve theta. Once we know theta, we can find the arc length. Arc length is L r into theta. R is given. So theta can be found from the perimeter. So we know r and theta, so we can calculate area of the sector. That is half LR. First we'll calculate L, and using that and the radius we can calculate the area, which is equal to half into small l into small r. Okay, so we have the perimeter of a sector of a circle of radius 15 centimeters is 80 centimeters. Find the area of the sector. Let us look into the working. So this is question 21, part A. Okay. So radius is 15 centimeters. Let us call it small r. Let us call it small r. Let us call it small r. So what are we given? We are given radius is equal to 15 centimeters. Say this is small r. Okay. And perimeter of the sector. Perimeter of the sector is given to be 80 centimeters. Okay, and what is perimeter in terms of r and theta? We have, say, this is sector. Say this is sector. So this is the sector angle, say it is theta, this is small r, this is small r, this arc length is, let it be small l. So what is perimeter? It is L plus, it is L plus r plus r. Okay. And then L, what is L in terms of r and theta? It is r into theta. Arc length, the length of this curved path, curved arc is r into theta plus 2r is given to be 80 centimeters. And substitute r here, it is 5, I'm taking r out, so it is 15 into theta plus 2 is equal to 80. Okay, I have taken r out, so r into theta plus 2, but r I have substituted 15. Now I'll bring 15 to this side. I have theta plus 2 from here. I can calculate theta. So theta plus 2, yeah. 5 cancels in this 3 times and in this 16 times. So theta plus 2 is 16 by 3. Here 3 is multiplying, and so on the other side it divides. Okay. In 15 I have cancelled 5 3 times, and in 80 also I have cancelled 5 16 times. On both sides I have cancelled 5 5. Okay, I have divided both sides by 5. Okay, now and I have brought this theta to the right hand side, so it is 16 by 3. Here theta is multiplying, on the other side divides. Now here theta can be obtained. Theta is, take 2 to the other side, it is 16 by 3, 3 minus 2, and 3 is LCM, 16 minus 2 means 2 by 1, so 2 into 3 becomes 6. So it is 10 by 3. Okay, so theta is this. This is in radians. Numbers means radians. Yeah. Now, huh. So what are required? What is us for us? We have to find area of the sector. Area of the sector. It is half into small l into small r. Area of a sector. Area of sector is half into arc length into radius. So it is half into, what is arc length? It is r into theta into r. What is r? R is 15 centimeters into theta. What is theta? Theta is 10 by 3 radians. 10 by 3 into small r. Small r is what? Small r is 15. Okay. This is the formula for area. Some people know the formula for area to be the formula for area of sector is theta by 360 degrees into pi r square. Okay, right? For the whole circle, theta is pi r square, means for the 360 degrees of angle. If a circle makes an angle of 360 degrees at the center. So for 360 degrees, the area is pi r square. So 1 degree area is pi r square by 360. Okay. And then for theta for sector we want area. So we have to multiply it by theta. So this gives the area of the sector. Okay. And for 360, you can as well write 2 pi in radians. Okay. Pi cancel. And this is what is happening. Okay. Theta into r square can be written as r theta into r. And this 2 is remaining. Okay. Yeah. This pi cancel. 2 remains. This is 2. 360 is 2 pi. So pi cancel, and then 2 comes here. That is half LR, half into LR. Okay. So some people know the area for sector is 3 by 360 degrees into pi r square. That can be converted into the terms of arc length and radius as half into LR. That's what I'm using. Okay. So I'm not doing anything new, but okay, we're converting into these variables L and R. Right? So let us simplify this. Now 3 into 5, 3 cancels in 15 5 times, 2 cancels in 10 5 times, 25 is 25 into 15 is 375. 25 into 55, 15, 25 are 125, 5 comes, 12 remains, 125 plus 1 into 25 plus 12 is 375. 15, 25 are 12, 25 are 300 plus 325 are 375. So these are square units. These are square units. Okay. So that's how we can compute the area of the given sector. So what we have done, what we are given radius to be 15 centimeters for a sector, and its perimeter is given to be 80 centimeters. Okay. So this radius, each of these radii is 50 centimeters. So what is formula for perimeter? It is r plus small l. That is L plus 2R plus R is 2R. L is what? It is R into theta. Right? As I have converted the formula for area in terms of theta, degrees, and pi r square into this one. You can also see that what is in the form of in the form of arc length. It is theta by 360 degrees into 2 pi r. Okay, for circle, circumference is 2 pi r, means at the center circle makes an angle of 360 degrees. So, for 1 degree, the arc length becomes 2 pi r by 360 degrees. And for sector, the angle is theta, so you have to multiply this by theta. Okay, and this degrees can be converted into radians by 2 pi, 2 pi, 2 pi, cancel it is r into theta. That's how L becomes r into theta. Arc length, this curved portion, the length of this curved portion becomes r theta. Okay, that's what I am using. Yeah. So I'm not using anything new. But yeah. Now between these two, take r out. It is theta plus 2. R for r substitute 15. For r you substitute 15, and then theta plus in 15 and 80 pi cancels 3 times here and here 16 times. Okay, and then bring 3 to the other side, it is multiplying here, it divides here, and take 2 to the other side is 16 by 3 minus 2. Plus 2 becomes minus 2, and here LCM is 3, 2 means 2 by 1, LCM is 3, 1 cancels in 3, 3 times 3 into 2 is 6, 16 minus 6 is 10 by 3. So this is theta, the number means it is radians. And then we need the area of the sector, it is half into LR, half into L is R into theta, or okay, into R comes, this is half into L is for R, you can write 15 into theta is 10 by 3 into R is 15. So 2 cancels in 10 5 times, 3 cancels in 15 5 times. Yeah. So it is 5 into 5 into 25. NR is 5 into 5 into 25 and DR is 1. There is nothing means there is 1. Here we don't have any visible factor, means it is 1. 1 is hidden. So it is 25 into 15 is 375. 25 are 125, 12 remains. 125 plus 1 into 25 plus 12 is 375. The 12, 50, 25 are 300 plus 5, 25 are 75. It is 375. So this is the area of the given sector. Okay? Yeah. So let us look into the next question. What is 21, part A. Part B. We have completed part A. We'll enter part B. Of course, in the exam, it is enough to find the answers for one of these question parts A and B. Huh. 21, question B. In the given figure, ABCD is a trapezium with AB parallel to DC. Find the area of the shared region. Keep the answer in terms of n. In terms of pi, I'm sorry, pi. So, ABCD is a trapezium. What is a trapezium? It is a quadrilateral in which a pair of opposite sides are parallel. Okay, and we in this quadrilateral we are given AB and CD are parallel. Means these two sides are parallel. And also some region is shaded. Region means it's part of the plane in which this quadrilateral lies. So this region, this part of the plane is shaded, and this part of the plane is also shaded. These each of these two is a sector. Okay, so this is sector angle, and this is radius. This is radius. So and this is curved line, curved portion. So this is a sector. Similarly, this also is a sector. These two are radii, each both of them equal to 6, and this is a curved portion, and this is a sector angle. So using the We need the area of the shaded region, means we'll find the area of this sector, we'll find the area of this sector, and we add both of those areas to get the area of this entire shaded region. Okay? Yeah. How to find, as we have done in part A, we can proceed. Yeah. Here, what is the use of that these two are parallel sides? A, B, and C, D, C are going to be parallel sides. Yeah. So we have to use these angles. Now A, B, and C are parallel. This angle is given to be 60 degrees, and these two angles become supplementary because they are interior opposite angles. They are interior opposite angles. They are supplementary. This is 60 degrees. So their sum becomes 180 degrees, so this becomes 120 degrees. So we get the angle of the sector, we know the radius, and area of the sector is r into theta. So we can calculate that. Similarly, these two angles here, these two angles are supplementary because again A, B, and C, D are parallel. These two are pair of interior opposite angles. Therefore, they are supplementary. Means their sum is 180 degrees. This being 120 degrees, this becomes 60 degrees. So we know the angle of this sector 2, and the radius is known for this sector. We can calculate the area to be r into theta, that is 6 into 60 degrees. 60 degrees should be converted into radians, and then we should calculate area. Similarly, here, angle is 120 degrees, convert that into radians and calculate the area. Once you get the areas of these two sectors, we will add them. That gives us the area of the area required for the region, shaded region. Okay, so let's go to the board. Yeah, it is this. So let's first calculate the area of this sector. We have a trapezium ABCD, and AB is parallel. AB is parallel to CD, and this angle is going to be 60 degrees, and this angle is going to be 120 degrees, and also for this region, shaded region, this line segment is 3 centimeters from here to here. Similarly, from here to here is 3 centimeters. So it is in the shape of a sector. Okay, whose radius is 3 centimeters. And this being 60 degrees, and this angle, this angle and this angle are supplementary. So if this is x plus, if I call this x plus 60 is 180 degrees. Therefore, x becomes 180 minus 60, that is 120 degrees. Okay, so for this sector, the angle is 120 degrees. This should be converted into radians. We know 180 degrees are pi radians. Pi radians are 180 degrees. Okay. So 120 is what? 120 is 2 into 60 degrees, and 60 degrees 1/3 of this. That is 2/3. That is right. But 2 into 60 is 1/3 of this. So it is 1/3 of pi. So it is pi by 3. Pi is 180 by 3 is 60. Okay. So it is 2 pi by 3. X is 2 pi by 3. Therefore, the area of this sector is area A1. Let me call this the area of this sector to be capital A suffix 1. So this is equal to half LR. Area is half LR. This is half into what is length here? It is r into theta into r. Okay. Arc length is r into theta. So this is half into radius is 3. So it is 3 into theta is 2 pi by 3. No, pi by 3, I'm sorry. Theta is, this is our theta. This is our theta. So theta is, this is theta. Theta is 2 pi by 3 into 2 pi by 3 into r. R is 3. Okay, these two cancels with this. So we are left with 3 pi. Okay, we are left with 1 into 3 into pi. Okay, this has cancelled with this, and this has cancelled with this. Right? So these two are left, 3 pi, and these are cancelled. Yeah. So area of this sector is 3 pi square units. Similarly, area of the second sector is again, it is half into LR, let me use some other symbols because the sectors are different, but the radii are different. Okay, so let me use capital L here. So this is half into, here it is capital R into some, let me call the sector angle to be phi. Okay, so capital R into phi into capital R. Okay, yeah. What is the area, the angle of this sector? Why is this sector? This radius is 6 units. This radius is 6 units. Both are centimeters. Okay, and therefore this becomes a sector. And now these two angles are interior opposite angles. AB is parallel to CD, therefore they are supplementary. So as before, here we have got X and 60 supplementary. Why? AB is parallel to CD. This is a trapezium, and we are given that AB and CD are parallel. Therefore, and these two being interior opposite angles, they are supplementary. That's how we got this. Similarly, here also, in this trapezium, these two sides are parallel, therefore, and these two angles, 120 and phi, being supplementary, we have that 120 degrees plus phi is 180 degrees. Okay, these two being in opposite angles, they are supplementary, means their sum is 180 degrees. From here, you can calculate phi. Phi is take 180 to the other side, so it is no 120. Yeah, degrees. So it is 60 degrees. 60 degrees is pi by 3. Pi is 180 degrees. 180 degrees by 3 is 60. So it is pi by 3. So you can now for phi you can substitute pi by 3. So it is half. And for capital R, we have to substitute 6 here. 6 into phi is pi by 3 into R is 6. Okay. Half into capital R is 6 units into phi is pi by 3 into R. Capital R is again 6. Now 2 into 3 is 6, that cancels with this. So we are left with 6 pi. Right? 2 into 3 is 6, cancels with 6. 1 into pi into 6 is 6 pi. And area of this region is 3 pi square units. Area of this region is A2 is 6 pi square units. So we have to add these two. Pi is common. 3 plus 6 into pi. 3 chocolates plus 6 chocolates or 9 chocolates. Okay, this is 9 pi square units. Okay, so this is the area of the given region. Okay, this is the required area for the region for the shaded region. Okay, yeah. So what we have done, we use the fact that in a trapezium, interior opposite angles are supplementary, and from that we could get the angle of this sector. Once we know the angle of sector and radius, we can calculate its area using the formula of it LR, where L is R into theta and small r is radius. Right? Here also by the same procedure we can calculate the area of this region and the required region. Yeah, the area of the shaded region, the entire shaded region is equal to sum of these two areas. Means this union this region union this region for this portion union this portion, that is the region for which we need the area. So we have to add these two areas, 3 pi and 6 pi, it becomes 9 pi square units. Okay, so that completes. Now let's go to the next question. It is 22. We want English version. Show that, question 22, show that 14 power n cannot end with the digits 0 or 5 for any natural number n. Okay? Show that 14 power n cannot end with the digit 0 or 5 for any natural number n. What is the condition that a number is divisible by 0? It should have 0 in its units place. Okay? And 14 is a positive integer. N is a natural number, means it is 1 or 2 or 3 and so on. So 40 power n is also a positive integer. And it is divisible by 0 only when it has 0 in its units place. Yeah, it is divisible by 0. It has 0 in its that number ends with 0 means what? It is divisible by 10. A positive integer ends with 0. It has 0 in it. It ends with 0 means in its units place you have 0. Means 10 becomes a factor for that positive integer. Means, yeah, once 10 is a factor means 2 and 5. 10 is 2 into 5, so 2 and 5 becomes the factors of that positive integer. Now, when you prime factorize 14, it is 2 into 7. Therefore, 14 power n is 2 power n into 7 power n. And in the, right? For a number to be divisible by 10, that 10 must, if 10 is to divide 10 for 14 power n, it also has to divide 14. Okay? But it cannot happen. Why? 14 is 2 into 7. It has 2, but not 5. That's how 14 is not divisible by 10. Therefore 14 power n is also not divisible by 10, and hence it cannot end with 0. How about 5? Can it end with 5? If a number ends with 5 means it is divisible by 5, right? Then only it can end with 5. Now 14. So once 5 is dividing this, means 14. It also if 5 divides 14 power n, it also divides 14. So but 14 is divisible by 1, 2, 7, and 14 only. 5 cannot divide 14. The 5 is a prime number and it is not present. It is not present in the prime factorization of 14. Therefore, 5 cannot divide 14, and hence it cannot divide 14 power n, and hence 14 power n does not end with 5. That is the argument we give. So let's give the working. Show that 14 power n cannot end with the digit 0 or 5 for any natural number n. Question number 22. Question number 22. 14 power n. Consider for natural number n, small n, capital N instead of natural numbers. For natural number small n, consider 14 power n. Okay? What is 14? This is 2 into 7 power n. Okay? This is 2 power n into 7 power n. Right? Yeah. Now, a number or 14 ends with 0 implies 14 is divisible by 14 is divisible by 0 by 10. I'm sorry, by 10. 14 ends with 0 means 14 is divisible by 10. So, or rather, 14 power n. Let's take 14 power n. 14 power n. 14 power n is divisible by 10. So this implies 10 divides 14. If 14 is divisible by 10 means 10 is a factor of 14 power n. Means 10 divides 14 power n. So 10 divides 14 also. From here you get 10 divides the base 14. But what is 14? It is 2 into 7. Okay. But then 10 is what? 10 is 2 into 5. The prime factorization of 14 is 2 into 7, but 5 is not present in this prime factorization of 14. So this is absurd. So this cannot happen, right? The 5 is present in the divisor, but not in the dividend. So this is absurd. That is impossible. Therefore, 14 does not end with 0. Okay? Because this hypothesis is leading to absurdity. This hypothesis is false. The assumption is false. Means we have the negation of this as assertion. So 14 cannot end with rather 14 power n cannot end with end 0. How about 5? 14 power n ends with 5. Let us assume this. Let 14 power n end with 5. Means what? means what? 5 divides 14 power n. From here you get 5 divides 14. But 14 is 2 into 7. This is the prime factorization. And 5 is a prime number. And in the prime factors of 14, you have 1, 2, 7 only. And 4, right? As prime factors. And 5 is not present. So this is impossible. So this situation is impossible. So this is impossible. Therefore, this is impossible. Therefore, what is the conclusion? Therefore, 14 power n does not end with 5. Okay? 14 power n 5 means 5. 14 power n ends with 5 means, yeah. 5 means 5 divides 14 power n, and hence 5 divides 14, but 14 has prime factors 2 and 7 only. 5 is absent here, therefore this is impossible situation. Okay, this has arisen because of this false assumption. This assumption. So this is false. Okay, means 14 power n does not end with 5. Okay. Here, let me. Nice. Okay. 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 Now, what we have done, n is a natural number, and we have considered 14 power n, means 14 is 2 into 7. So power n is 27 power n, the 2 power n, 7 power n, and we have to show obtain that 14 power n cannot end with 0 or cannot end with 5. Okay. First let us start with 14 power n ends with 0. So this gives that 14 power n is divisible by 10. If a number has 0 in its units place, 10 becomes a divisor of that. Okay. So if 10 divides 14 power n, means what? This implies that 10 divides 14 power n. This implies, this implies, okay. So means from this we get 10 divides 14 power n. So it has to divide. 10 is 2 into 5. So it has to divide 14 also. Okay. Because 2 into 5 are prime numbers. So it has to divide 14 also. Okay. So 10 divides 14. And 14 is 2 into 7. 10 is 2 into 5. Though 2 is present, 5 is not present in 14. 5 is present in 10. But 5 is not present in the prime factors of 14. And hence, this is absurdity, impossible situation. This happened because of this assumption. So our assumption is false. Means 14 power n does not end with 0. Similarly, let us assume 14 power n ends with 5. Means 5 divides 14 power n. And here 14 power, so 5 divides 5 is a prime number. Therefore, 5 divides 14 also. 14 is 2 into 7. So, but 2 and 7 are primes, but 5 is prime, and 5 is not equal to any of 2 and 7. So this is absurdity. This is impossible situation. 5 cannot divide 2 into 7. Therefore, our assumption is false. Means 14 power n does not end with 5. So conclusion is what? 14 power n does not end with 5 or 0. Okay. In mathematics, this or means this statement is true, this statement is true, and both of them are true. That's what or conveys. Okay. That's how we have completed the answer. That is question 22. show that 14 quadrant cannot end with 0 or 5. I have used does not. Okay. Yeah. Now let's go to the next question. I have used cannot in the same sense as does not. Okay. I have taken cannot and equal to does not. Yeah. 23. Part A. If sine of 2a plus b, 2a plus 3b is 1 and cos of 2a minus 3b is root 3 by 2, where 2a plus 3b, this angle is between 0 degrees and 90 degrees, less than or equal to here, and a is positive, greater than b, then find a and b. Okay. So we are given the values of these two ratios, sine theta and cos some phi. Okay, these two angles are different. This is 2a plus b and 2a, this is 2a minus 3b. This is 2a plus 3b. Yeah. Now, and this angle is between 0 and 90 degrees. For which angle theta between 0 and 90 degrees, sine theta is 1? It is for when theta is 90 degrees. So sine 90 degrees is 1, so 2a plus 3b can be taken as, because it lies between this and this. It is once only one in this interval. It is theta is right for a single theta in this interval. Sin theta is 1. So that theta is 90 degrees. So 2a plus 3b becomes 90 degrees. Similarly, a is greater than b. Yeah, and here 2a minus 3b. We assume 2a minus 3b is in the first quadrant. And in the first quadrant, cos theta is root 3 by 2 means sin theta is half, cos theta is root 3 by 2. So this is 2a minus 3b becomes 30 degrees, and 2a plus 3b is 90 degrees. From these two equations, we can solve a and b. So that's how we proceed. Let us look into the working. So if sine of 2a plus b is 1 and cos of 2a minus 3b is root 3 by 2 and 0 degrees is less than 2a plus 3b is less than or equal to 90 degrees and a is greater than b, then find a and b. Okay, so let's go to the working. Question number 23, part A. Sine of 2a plus 3b is 1 and cos of 2a minus 3b is root 3 by 2. We are given 2a plus 3b is between 90 degrees and 0. Okay. From here, we see, I think we are given a and b positive. We are given a is greater than b, and b, if b is positive. Okay, what is b given to be? You have to assume b, yeah, yeah, a plus 3b is positive. So we have to assume b is positive too. Okay, so what happens then? So what happens? B is positive, so 2b is less than 3b, right? And from here you get minus 2b. Minus 3b. I'm sorry. This is. I want to show that minus 3b is less than 3b. Means from here you, right? I want to show minus 3b is less than 3b. So I get 6b is great. You bring minus 3b to the other side, becomes 6b, it has to be positive. So this must be there. Yeah, that's don't go into that. Just for your clarity, I'm giving this, but in exam, you don't need to bother about this. Yeah. Now, cos of 2a minus 3b is root 3 by 2. You assume this is an angle in the first quadrant. So this happens when your 2a minus 3b is 30 degrees. Okay, and for cos, we know cos 30 is root 3 by 2, sin 30 is half, cos 30 is root 3 by 2. So from here you can conclude that 2 minus 3b is 30 degrees, and also from here you can conclude that 2a plus 3b is 90 degrees. Okay, so sin 2a plus 3b is 1, and this when 2a plus 3b lies between these two degrees, so your angle has to be 90 degrees only. Okay, then only this is possible. So this This condition gives you 2a plus 3b is 90 degrees. And this condition gives you 2a minus 3b is 30 degrees. Call this first equation, call this second equation. Now, if you add first and second equations, what do you get? Minus plus 3b minus 3b cancel out. 2a plus 2a is 4a is equal to 90 plus 30, 120 degrees. Okay, so this gives you a is 30 degrees. About b, you substitute the value of a here in 1. So 1 implies 2a, 2 into 30 plus 3b is 90 degrees. So 2 into 30 is 60. Take it to the other side. 3b is 90 degrees minus 60 degrees. 2 into 30 is 60. Take it to the other side. It becomes minus 60 degrees. This is 30 degrees. So 3b is 30 degrees. So this gives you b is 10 degrees. Okay. That's how your a is greater than b. This is given. Yeah, 30 is greater than 10. Okay, and we have got the values of a and b. A is 30 degrees and b is 10 degrees. Okay, so that completes. So what we have done here, we are given sine of 2a plus 3b to be 1 and cos of 2a minus 3b equal to root 3 by 2. We are asked to calculate the values of capital A and capital B. You have to assume capital A, capital B as constants and work out. Okay, when your 2a plus 3b, yeah, which is given to be between 0 degrees and 90 degrees, right? So your 2a plus 3b has to be 90 degrees because of this condition. Your sine value is 1. Okay, sine ratio value is 1. Therefore, this angle must be 90 degrees. Similarly, the cosine value of this difference is given to be root 3 by 2. Okay, and if you impose that b is positive, you can obtain that this is an angle in the first quadrant, and we know that when angle is in the angle for which the angle which is in first quadrant, for which cosine is root 3 by 2 is cos 30 degrees. Sin 30 is half, cos 30 is root 3 by 2. So this angle 2a minus 3b has to be 30 degrees. So 2a plus 3b is 90 degrees and 2a minus 3b is 30 degrees. Call this first equation, call this second equation, add both of those two equations. Plus 3b minus 3b cancel out, 2a plus 2a is 4a is equal to plus 3b minus 3b cancel out is equal to 90 plus 30 is 120 degrees. From here you get 4 cancels in 120, 30 times. So capital A is 30 degrees. Now substitute this value of a in any of these two equations. I have added it in the first equation. So 2 into capital A is 30 plus 3b is equal to 90 degrees. 2 into 30 is 60. Take it to the other side. 3b is equal to 90 plus 60 becomes 9 minus 60 when it goes to the other side. 90 minus 60 is 30 degrees. So 3b is 30 degrees. 3 cancels in 30 10 times. So b is 10 degrees. And we are given that a is greater than b. We are greater than b. Yes, this is true also. A is 30 and b is 30 degrees and b is 10 degrees and a is greater than b. And so this is our final solution, right? This is our final solution. That is capital A is 30 degrees and capital B is 10 degrees, right? So with this, yeah, let me see whether I can go to the next question. Yeah, I'll try to complete this and stop. Okay, let's go to the next question, 23b. Find the figure from the 23b. From the given figure, find the value of sine alpha. This is a triangle and this is right angle, and from this vertex a right projection is done, and for this right this line segment is making an angle of 90 degrees with the base. Okay, and from this vertex to this vertex distance is 6 centimeters. From here to here, from the foot of this projection, it is 3 centimeters. From this point of projection to this vertex, the distance is 9 centimeters. 9 centimeters. We are asked to find the value of sine alpha. How can we do that? Yeah. Now this is a right triangle. This angle is, let me call this capital A, capital B, capital C. Capital A is a right angle. So capital A, capital B, capital C is a right triangle. Okay, this side is given, AB is given, and BC is also known because this is 3 units, and from here to here is 9 centimeters. So this BC will be 3 plus 9 is 12 centimeters. So BC is also known. In fact, BC is the hypotenuse of this right triangle. BC is the side opposite to this right angle. So it is hypotenuse. Hypotenuse given, one of the other two sides is given. We can calculate the second side. Okay, other than hypotenuse by using the Pythagorean rule. What does Pythagorean rule say? If this is x square plus x square is 12 square. X square plus 6 square is 12 square. From that we can calculate x, the length of this side. Once we get the length of this side, right, we know the length of this side also in this small triangle. Let us call this foot D. So it is capital A, capital C. This also is a right triangle because angle D is 90 degrees. Okay, now we know DC is 9 centimeters, and we obtain from the larger triangle ABC, we obtain the side length of this side AC. Okay, we know the, and for the small triangle, this side becomes hypotenuse because it is opposite right triangle. So we, in this small triangle, hypotenuse is known and this side is known. We can calculate this side using hypotenuse rule, Pythagoras rule. Okay, once we get this side, which is opposite to alpha, and we know this hypotenuse also, we can calculate sine alpha. Sine alpha is opposite side by hypotenuse. So when we know this opposite side and this hypotenuse, we can calculate sine alpha. That's what we are asked for. Let us proceed. Okay. From the given figure, find the value of sine alpha. So this figure is given, this side is given, this side is given, this side is also given. So this side is given completely in this larger triangle. And this angle is assumed to be small alpha. This angle is right angle, and this vertex is projected onto this base. Right? So this line segment makes an angle of this is perpendicular to this base of the larger triangle. Okay, and therefore the right triangle. So let's look into the working. So let me call this capital A, capital B, capital C, and this point capital D. This is capital D. Now in the triangle ABC is right triangle. Okay, and we have AB equal to 6 centimeters, and we have BC is equal to 3 BD plus DC. D is the foot of the perpendicular from A onto BC. So it is BD plus DC. So it is equal to 3 plus 9 centimeters. It is 12 centimeters. Okay, from BC is from here to here. It is the length of this line segment from BD plus the length of the line segment DC. That's what I wrote. 3 plus 9 is this the length of the line segment BC. Okay. So from here to here, it is 12 centimeters. So we know in this the right triangle capital A, capital C, we know two sides. That is one side, one this side, and this hypotenuse. This is hypotenuse because capital A is right triangle. So we can apply Pythagorean rule. By Pythagorean rule implies that let me call this AC small x. So x square plus x square is equal to 12 square. Pythagorean rule says hypotenuse square is equal to sum of the squares of the other two sides. They are 6 and x. So square of 6 square is this. Square of 66 square, square of x is x square. Add them. Their sum is equal to hypotenuse square, which is equal to 12. So square is 12 square. So from here you can calculate x square. This is x square is equal to 12 square is 144, and 6 square take it to the other side. 6 square is 36, take it to the other side. It is minus 36. Okay, so 144 minus 36. 44 minus 36 is 8. So it is 108, right? Yeah, 144 minus 36 is 108. So what? So this is nothing but So AC. So we have got AC is equal to root 108. So we have got this to be root 108. Okay. Now Now let us calculate. Let us calculate AD, right? Now let us consider triangle ADC. Triangle ADC is right angle. Is a right angle. Okay. So again, we can apply Pythagorean rule or Pythagorean rule. So it gives out AD square plus DC square, that is 9 square, is equal to hypotenuse square, that is 108. Okay. For the triangle ADC, this angle is right angle. It is given. Therefore, triangle ADC is right angle. Therefore, we can apply Pythagorean rule. What does it say? Hypotenuse square, that is x square, that is 108. Square root is that base. Square of root 108 is 108. Okay. So it is equal to sum of the squares of the other two sides. That is 9 and AD. So AD square, the other two sides in this triangle ADC are capital AD and DC. DC is 9. So it is AD square plus 9 square. From here we can calculate AD. This implies AD square is equal to 108. 9 square is 81. Take it to the other side. So this is 27. 8 minus 1 is 7. 10 minus 8 is 2. Okay. So AD square is this. So this is 3 cube. This is 3 cube. So AD becomes how much? AD is root 3 cube. That is 3 root 3. Root 3 into 3 square. That is 3 root 3. So we have got AD here. It is 3 root 3. Okay. It is 3 root 3. Yeah. We are asked to sin alpha. How can we find sin alpha? Yeah. What is sin alpha? Sin alpha is opposite side by hypotenuse. Okay. So we can calculate sin alpha. Yeah. In this right triangle, yeah, in this right triangle, sin alpha is 3 root 3, opposite side by hypotenuse AC. That is 3 root 3 by root 108. So yeah, sin alpha is equal to AD by AC. This is equal to, what is AD? 3 root 3 by root 108. AD is root 108. AC is root 108. AD is 3 root 3. Okay, simplify this. 3 root 3. Let us simplify root 108. What is root 108? What are factors for 108? 108 is 9 devices. So 9 into 12. Now this is 3 square into 3 into 2 square. Okay, 108 is 12 is 3 into 4. So square root of 108 becomes 3 into 2 into 3, root 3. Okay, I'm taking square roots. Square root of 3 square is 3. Square root of 3 square is 2 into root 3. That is 6 root 3. So this is by 6 root 3. This is right. Root 108 is 6 root 3. Root 3 cancel, being non-zero. 3 by 6 is half. Okay, and sine theta is half, means theta must be 90 degrees. Must be 30 degrees. Okay, theta. So this is equal to sine 30 degrees. Right? It is half. It is becoming half. And alpha is an acute angle. Therefore, sine 30. This half must be taken as sine 30. So sine alpha is sine 30. Therefore, alpha becomes 30 degrees. Yeah, we are asked only sine alpha. I'm sorry. So this is unnecessary. I'm sorry. We can stop here itself. Okay, sine alpha we have got as half. Okay, here we are asked to sin alpha, we got that is half. Okay, so let us see. Let us explain again. Right, what are we given? What are we given? We are given triangle ABC, and this capital A is right angle, and this A is projected onto BC, and angle D is going to be right angle, and AB is going to be 6 centimeters, and BD is 3 centimeters, DC is 9 centimeters. So AB is 6 centimeters, and what is BC? BC is BD plus DC, and 3 plus 9 is 12 centimeters. And so this in the triangle ABC, this is right angle, therefore BC is hypotenuse, and 3 plus 9 is 12 is BC. So we know that in the triangle ABC, we know the hypotenuse, and we know the second side and third side can be calculated using the Pythagorean rule. What does it say? It says 6 square plus x square is hypotenuse square, that is 12 square. Therefore, from here you can call this AC x, we can calculate x. That takes 36 to the 6 square is 36, take it to the other side, 144 minus 36, that is 108. Therefore, x becomes, let's take square roots on both sides, so x is root 108. Okay, next, you calculate yeah, what do you want? We want sin alpha. So we know CD, we know DC, and we know AC also. In the the triangle ADC is right angled at D, therefore it is a right triangle. So we know the hypotenuse. This becomes hypotenuse in this triangle ADC. AC becomes hypotenuse. We know this side to be 9 centimeters. If we know, to find sin alpha, we need opposite side of hypotenuse. We know hypotenuse. We need the length of the opposite side. So we are finding this using the Pythagorean principle. Okay, we know this side to be 9 centimeters, and the hypotenuse square is 108. So from this we subtract 9 square and we obtain the square of AD. From there we can calculate capital AD. That's what we are doing. Yeah. Triangle ADC is right angle, AD square, that is right. That opposite side square plus 9 square. This base square is equal to hypotenuse square, that is 108. Right? That is 108. Square of this is 108. So take this to the other side. 80 square becomes 108 minus 81, that is 27. Okay, 8 minus 1 is 7, 10 minus 8 is 2. This is 3 cube. So 80 square is 3 cube. When you take square root, 80 becomes 3, square root of 3 into 3 square, that is 3 root 3. 3 root 3. Now you need sin alpha. Sin alpha is 80 by AC. What is sin alpha? Sin alpha is opposite side by hypotenuse. Opposite side is AD and hypotenuse AC. So it is AD by AC. AD is obtained to be 3 root 3. 3 root 3. AD is obtained to be 3 root 3 from here. And AC is root 108. What is 108? It is 9 12s. The 9 is 3 square. 12 is 3 into 4. That is 3 into 2 square. Take square root of 108. So here comes 3, here comes 2, and root 3 comes. So it is 6 root 3. So AD by AC is 3 root 3, AD is 3 root 3, AC is root 108 is 6 root 3. Substitute that. Root 3 cancel, being non-zero, 3 by 6 is half. So that's what we are asked. We are asked to compute. We are asked to compute sin alpha, and we obtained that as half. So this completes the solution. Thank you. Here I want to stop. Already I have taken 57 minutes. Okay, we'll continue in the next class. Thank you very much. God bless you.